Hi Geometry, this is our Unit 6 review, and I'm going to discuss selected answers. So let's review circles. Circles were lessons 4 through 6 in our book, lessons 4 through 6. So in number 1, to find the center and radius, we would look at our HK, which means we have to think the opposite of the numbers that we see in our formula. This is our x minus h squared plus my y minus k squared equals my r squared. So my radius would actually be the square root of 9 or 3. For the second one, I want to write the equation. So it would be x minus my h, which would actually be x plus 2, because a minus negative 2 would give me a plus 2, plus y minus 5 squared, and then my radius squared would be 6 squared or 36. Finding the center and radius when it is in standard form. This is where I do step 1, I put my x's together and leave a space. Step 2, I put my y's together and I leave a space, and I move my constant to the other side, so I'm going to subtract 10 from both sides. Step 2, I complete the square, so I take my b term and I divide by 2 and square it. That's 4 squared, that's 16. When I add 16 to the left, I want to make sure I add 16 to the right. And I do it all over again for my y term. So I get negative 4 divided by 2 squared, which is negative 2 squared, which is 4. So I add 4 to the left and I add 4 to the right to keep it balanced. So now, on the left side, my x squared plus 8x plus 16 trinomial factors into the square root of the first, square root of the last, sine from the middle, and my y trinomial factors into square root of the first, square root of the last, sine from the middle, and then lastly my negative 10 plus 16 plus 4 would give me a positive 10. So my center is the opposite of what I see, negative 4, 2, and my radius, you could say it's the square root of 10, or that's approximately 3.2 units. So to graph my circle, I would put a dot on my center, which is 2, 1, and then my radius would be just 5, so I would go up 5, 1, 2, 3, 4, 5, right 5, 1, 2, 3, 4, 5, left 5, I do the same thing. Once I have all 4 of those dots, I would connect them all to make my circle. Now, to figure out if a point is on this circle, I'm going to plug this point in for x and y and see if it makes my equation true. So I'm going to do negative 2 minus 2 and squared plus 2 minus 1 squared. I'm going to see if that's equal to 25. So negative 4 squared plus 2 minus 1 squared, and I'm trying to see if that is equal to 25. So then I get 16 plus 1, which does not equal, sorry, that would be 17, and it does not equal 25. So no, my negative 2, 2 is not on circle. So then let's keep going. Now we're parabolas. Parabolas were lessons 7 and 8 in our workbook. Write the equation of the parabola with focus. So this is my AB, and this is my y equals k. So I have x minus my a, which gives me a plus 2, because of minus minus, plus y minus 6 squared equals y minus 4 squared. So now I want to write that in vertex form. So I'm going to leave my x term alone. I'm going to multiply out my y terms, so I get y squared minus 12y plus 36 equals y squared minus 8y plus 16. So now I want to get my y terms on one side. I think I'm going to add the 12y over. So I get, I'll end up getting 4y over here. Oh, step 3, my y squared's canceled. Forgot to do that. I'm also going to subtract the 16 over. So now on the left side, I still have that x plus 2 squared. It hasn't went anywhere. My y term canceled. And it looks like I have a plus 20 equals my 4y because my 16's canceled. So now I'm going to divide by 4, divide by 4, divide by 4, and it looks like my final answer is y equals, because my 4's cancel, and we're going to write that as a 1/4 in front of x plus 2 squared plus 5, and that would be my vertex form. So number 6, this is my focus AB, this is my directrix, so I know the equation of my parabola would be x minus 6 squared plus y minus 2 squared equals y minus 4 squared. So now I'm going to plug in the 2 for my x and the negative 1 for my y. So I get 2 minus 6 squared when I do that, and negative 1 minus 2 squared. And I'm trying to see if that equals negative 1 minus 4 squared. If it does, then 2 negative 1 is on my parabola. If it does not, then no, it is not on my parabola. So this is a negative 4 squared plus a negative 3 squared. And I want to know if that's equal to negative 5 squared. So 16 plus 9, is that equal to 25? And it is. So yes, 2 negative 1 is on my parabola. So let's take a look at the next. So this is review of lessons 9 through 12. This is my parallel, perpendicular, and slope lessons. So the first one, a line with a slope of 2/3, so m equals 2/3, and it passes through this point. So I would do my y minus my k, so y minus 6 equals my slope times x minus my h, and I would be done. For b, if it's parallel to this line, then I know my slope's got to be negative 2 in order for them to be parallel, and it passes through 1, 4. So y plus 4 equals negative 2 times x minus 1. The next one says it needs to be perpendicular to this. So the slope of this line is negative 2/3. So the perpendicular slope would be positive 3/2. And it goes through 0, 2. So I would have y minus 2 equals 3/2. X plus 0. Or you could have x minus 0, or you could just drop the 0 altogether and just have the x. 8's the exact same thing over again, so I'm going to skip over that. Number 9, I want to find the slope, and I notice that this is in standard form, ax plus by equals c, so I need to solve that for y. So I'm going to start by subtracting 4x over. I get 5y equals negative 4x plus 10. I'm going to divide everything by 5 to get the y by itself. So then I get y equals negative 4/5 x plus 2. Oh, sorry, that's negative 4/5. I'm not sure why I wrote that. So it looks to me like the slope of this line will be negative 4/5. What's the slope of the line containing the points negative 2, 3, and 4, 1? You could set up your slope formula. The difference in your y's, for example, 3 minus 1, over the difference in your x's, negative 2 minus 4, would get me what? 2 over negative 6, or negative 1/3 would be the slope of that line. So in the next problem, before I can answer these questions, I need to figure out the slope of the line in that graph so that I can pick out which ones are parallel, perpendicular, or neither. So let's take a look at this. It goes through this point, and it looks like it goes through this point. So I have a rise of 1 and a run of 1, 2, 3, 4, 5. So it looks like my slope, which is rise over 1, would be a rise over run would be 1/5. So anything parallel would have a slope of 1/5, and anything perpendicular would have a slope of negative 5. So let's go through this. This slope is negative 2, so this guy is neither. This slope is 0.2, but remember 1 divided by 5 is 0.2, so this is actually the same number. So this guy is parallel, they have the same slope. This slope is negative 5, so they would be perpendicular. This slope is positive 5, so it would be neither. It's not 1/5 nor negative 5. This slope is 1/5, so they would be parallel. And 5x plus y equals 3. I can't tell by looking at it, so I'm going to solve for y and subtract 5x from both sides get y equals negative 5x plus 3. Since my slope is negative 5, then I know that that line would be perpendicular to the one given. So then, and then number 11 is the exact same problem as number 10. So take a look at that one. Let's see what's on the next page. So this one, it wants me to graph the line of y equals x minus 5. So this is my y equals mx plus b, where my b is negative 5, and my slope is positive 1. So that's up 1, right 1, up 1, right 1, up 1, right 1. And I'm just going to work all the way across my circle. It's really hard on my iPad to draw a nice line anyways. So I'll just draw a line through all these little slope points I got. This is my line y equals x minus 5. It certainly looks to me like these guys are going to intersect at 8, 3, and down here at, what is that, 1, negative 4. So I actually know that 8, 3, and 1, negative 4 are definitely on my blue line. I graphed that blue line. I did the slope dots. Those points are definitely on the line. So it looks like it's intersecting at 1, negative 4 and 8, 3. So now I'm going to verify that these points are also on the circle. I mean, they look like it, but I don't really know any points on the circle for a fact except the ones that are at the endpoints in my diameter. Those are the only coordinates that I know for a fact. So I'm going to verify it by substituting each one into the equation of my circle and seeing if it makes it true. So 8 minus 5 squared plus 3 plus 1 squared, and I want to know if that's equal to 25. So I get 3 squared, which is 9, plus 4 squared, which is 16. That indeed is 25. So yes, 8, 3 is on my circle. It's on my line. It's one of my intersection points. And I would do the exact same work for 1, negative 4. So now let's jump down to 13. It wants me to graph the circle with a center of negative 1, 1, because I have to think the opposite of what I see. So that center is right there. And then it looks like my radius is the square root of 64, 8. So I'm going to go up 8. I'm going to pause while I count these out on this little tiny diagram on my iPad, and then I'll come back. Hopefully we have the same circle. Hey, I forgot to hit that record button. So first I graphed the blue circle. I counted up 8, and I counted right 8, counted left 8, or you could just use your numbers and subtract to find out where you're supposed to be. And I drew my blue circle. And then I had to graph the line y equals 1. So I went to y equals 1 on the y-axis, and I drew my horizontal line. And it looks like it's intersecting at 7, 1 and negative 9, 1. And they say, where do they intersect? Verify. So you guys, I know that they're on my line, so now I'm going to verify it's on my circle. I plug in my 7 for x, and I plug in my 1 for y, and I'm trying to see if it equals 64. So I get 8 squared plus 0 squared, and I definitely know that that's 64. So yes, 7, 1 is on my line. I'm going to do this, or I'm sorry, on my circle. I'm going to do the same thing for negative 9, 1. Okay, so let's jump down to the next question. It says, graph the equation. So I'm going to graph my circle, which is 3, 2. So over 3, up 2. And I've got my center here. And my radius is 5. So I'm going to go up 5 to 7. I'm going to go left 5 to 8. That's right, 5, sorry. I'm going to go left 5 to negative 2. And I'm going to go down 5 to negative 3. And I'm going to pencil in my circle. And then I'm going to graph the line y equals 1/2 x minus 2. This is my slope, 1/2 over x. My y-intercept is negative 2. So I'm going to go to negative 2 and put a dot. Ooh, that's one of my intersection points. And now I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And it looks like my other point is here at 8, 2. My first point was at 0, negative 2. And Those points are definitely on my line because I graphed my line with slope. So I know those 2 points are on my line. I'm going to verify that those 2 points are on my circle. So I'm going to verify that 0, -2 is on my circle, and I'm going to verify that 8, 2 is on my circle. And by plugging them into my circle equation and showing that it makes it true. All of those are from lesson 13 in our workbook. This is to the 4th page. I want to do 17 and 18 first because these were also lesson 13, but these were from our supplemental worksheet. That worksheet was solving systems of equations to find my intersection points. So on the first one, it would help me if I knew what y was equal to, because then I could substitute in for y in my bigger equation, the bottom one, and then solve for my x. So I'm simply going to add the 2x to both sides, and I get y equals 2x plus 3. I'm going to plug that in for y in my second equation. So I get 2x plus 3 equals x squared minus 2x minus 9. I'm going to subtract the 2x over. I'm going to subtract the 3 over, and I get 0 equals x squared minus 4x minus 12. I have to do that because it's quadratic, and I can't solve it unless I get it equal to 0. So now I've got a diamond, -12 at the top. I've got my -4 at the bottom, and I try to think of two numbers that add to -4 by multiplying to -12. That looks like it's -6 and 2. So I get x minus 6 and x plus 2. When I set each of those equal to 0, I get x, takes me longer to write it out. I get x equals 0, or I get x equals -2. So I'm partway done. Now I need to find the y coordinates that go with those two intersection points. You could plug it back into either equation in the system. I'm going to use the linear equation. So I get y equals 2 times 6 plus 3, y equals 12 plus 3, or y equals 15. So it looks like 615 is an intersection point. Here I'm going to plug a -2 in for x, so y equals 2 times -2 plus 3. So it's -4 plus 3, or y equals -1. So it looks like -2, -1 is an intersection point of my two graphs. And I could check that on Desmos. The second one, I already have a y equals, and so I could simply substitute x minus 2 into the top equation for y. So I get x squared plus x minus 2 squared equals 20. I can solve this for x. I'm going to multiply out my x minus 2 squared and get x squared minus 4x plus 4 equals 20. Again, it's quadratic. I'm going to get everything on one side. Minus 4x minus, 16 equals 0. And I want to remind you that this isn't really one with an a, that's 2, because there's a GCF. So let's go ahead and divide both sides by that GCF so we can get rid of it. And that makes this problem x squared minus 2x minus 8 equals 0, -8 at the top, -2 at the bottom. I try to think of my two numbers. It looks like it's going to be -4 positive 2, x minus 4, x plus 2 equals 0. So x equals 4 or -2. And then just like last time, I'm going to plug those back in. When you plug them in, you'll find that you get 4, 2, and you get -2, -4, and that would be your two intersection points. So let's go back up to the top of the page and finish off our unit. This is lesson 14. So in 14, it was about geometric proof, proving something with our geometry. And so this is going to be a quadrilateral, means it has 4 sides, and I'm going to prove it's a parallelogram. So I'm going to graph these 4 points, and let's come back together at that time. So now that I've done that, I can clearly see that if this is a parallelogram, AB should be parallel to CD. So I'm going to find the slope of AB, and I'm going to find the slope of CD, and I'm going to show that they're equal to each other. I can also clearly see that AD and BC are opposite sides. I'm going to find the slope of AD, and I'm going to find the slope of BC, and I'm going to show that they're equal to each other. And then I will have shown that opposite sides have the same slope. That means opposite sides are parallel. In other words, it would be a parallelogram. So You can look at the work on the page, but when you do this, when you plug in your numbers in the slope formula, I believe you get 0 and 0 for these two, and you get 5 halves and 5 halves for these two. And then this is how, since opposite sides have the same slope, ABCD is a parallelogram. So let's take a look at 16. Again, plot your 3 coordinates. What is it? 0, 1, 3, 4, 5, 2. So this is my right triangle. I'm going to assume that that is my right angle right here at B. So it wants me to show, that it's a right triangle. Well, a right triangle has to have a right angle. So I'm going to need to find the slope of sides AB and slope, it looks like BC. And what I want to show is that they are opposite reciprocals. You could also find the slope of AC. That would be fine. But you're going to find that it's not one of my opposite reciprocals. It's not perpendicular to one of the other segments. It's my hypotenuse. So you can find it, but you don't really need its slope. So let's do AB together. The slope of AB then would be the difference in my y values, so 4 minus 1, over the difference in my x values, 3 minus 1. Looks like I'm getting 3 over 3, or 1. And then my slope of my BC, so again, I'm going to do the difference in my y values, so I'm going to do 4 minus 2. Then I'm going to do the difference in my x values, so 3 minus 5. Looks like I'm getting 2 over negative 2, or negative 1. Now, I don't love these two answers, but you can think of one as 1 over 1, and you can think of negative 1 as negative 1 over 1. So technically, they are opposite reciprocals. It's just a little less obvious than like a 1/2 and a negative 2, for instance. So anyways, I've shown that AB, since AB is perpendicular to BC, or you could say since AB and BC have opposite reciprocal slope, something along that line, then triangle ABC is a right triangle. So I hope that was helpful, and I will see you in class. Thanks. Bye.